Hello, me again. In this video, I want to start talking about writing conventions of mathematics in general. This is more of an overview type of conventions, and in the next part, which I'll post on Thursday, I'll be a little bit more specific about the details of the rules of what you can write. Okay, let's jump right to it. Okay, so number one is write in paragraph form. So the purpose of writing proofs is to communicate the truth of mathematical statement and its correctness of your argument to a human reader. Um, so uh, you've seen an example, maybe like unreadable proofs through the Principia Mathematica example that we talked about last week. Um, the overwhelming consensus is that using everyday language, ordinary prose, is much better suited to be able to communicate the truthness of the statement rather than uh, lots of symbolic statements. I know symbolic statements are many times more precise than everyday language like English. Um, but still, it is much easier to understand. So that's the preferred form. They do have it, the symbolic statements definitely does have its place, and it should be in there when precise statements are required. Um, but overall, you should be writing um, in everyday language. So you should be forming paragraphs, sentences, and so on. All right. So number two, use proper English. So just because you're writing mathematics does not excuse you from not using proper grammar or punctuations or spelling. So these things changes the meaning of what you're saying. So it is important to be as clear as possible. Um, People have different skill levels of writing English in proper grammar and so on. There are a lot of international students here and so on. And I don't expect everybody to be able to be a master of English language. Although this is a writing course, so I do want you to practice and try to improve the clarity of how you can communicate, even while writing about mathematics, especially while writing mathematics, because precise meaning is very important in proofwriting. This is something I mentioned before, but your writing depends on who the audience is. Um, and so for this class, you should be writing your proofs as if you're trying to convince your fellow student in this class. Not not especially. I don't mean somebody else you know in the class or your friends and you know how to communicate with them, but a random student who you don't know, who are taking the same class with the same prerequisite of this class. So you want to be properly stating like to back up what your arguments are, and you should be trying to convince them. Okay. Um, More specifically, the audience. I know I'm the one who ends up reading your proofs when you submit your homework assignment, but you shouldn't be writing towards me. So if you're using specialized mathematical knowledge that you learn from other upper division math courses, then you should be convincing me why that's true. Um, you shouldn't be writing things like, well, because you're PhD in mathematics. Um, you should be trying to writing to your colleagues. Okay. And this is something that goes along with that as well. You should try to include the correct amount of detail in your proofs. This is a question that a lot of people will struggle with and ask themselves over and over. How much detail should I include? Like, this statement seems like obviously a true statement. Should I go further than that? In this class, I want you to lean towards working out those tedious details than not. So try to do that. You might realize, oops, when you're writing out details and well, should I go into more details? Um, but I'm not sure how to write out the details. Like I might have to go back a chapter and look into axioms for me to be able to go a little bit further. And if you're not sure how to do that, that's probably a hint at why you should go into more detail. Is because you are not able to fill in the gap. Um, there's something that it's an opportunity for you to learn in more detail why this seemingly obvious statement, but you're not sure how to fill in the gap. Like that's a learning opportunity right there. So please try um, to go into as much detail as you can. And if you're not sure, ask me or ask somebody on the discussion board um, or Discord. Um, Number 5, state or restate what you're proving um, and label your theorems clearly. Um, so let's say a homework problem says something like, if x is a real number, show that x squared is greater than or equal to 0. Maybe this is the statement you want to prove. When you're writing up your solution, when you're typing up the solution, you should recast the statement as a theorem. So theorem, if x is a real number, then x squared is greater than or equal to 0. And then proof. And then write out your argument why that's true, maybe using axioms or proposition at the end of the chapter 1. And when you're done with the proof, put a black box or white box or QED, which indicates the end of the proof. QED you might have seen at the end of proof that some other people write. That's Greek, short for quad erat demonstratum. This could be a typo here, but basically means which was to be demonstrated. So it was a demonstration of why that theorem was true. Um, so that's why some people write QED at the or say QED at the end of the proof. If you don't want to do that, it's very common to put a black or white box at the end of the proof to indicate where the proof ends. So you should do that as well. Okay. And one more statement. So why is it true? So everything you write down should be true. So every mathematical conclusion you reach or you write down in intermediate steps must be justified by one of 6 ways or more than one of 6 ways. And here are the 6 ways you can kind of write down without going any further. So number 1, something you might write down might be just true by an axiom. So in chapter 1, we learned of 15 different axioms that we can use about real numbers. If it's one of those facts, you could just write it down. No questions about it. You could also write down something if it was a theorem that was proved earlier. So if it's a theorem that's in the textbook, you should cite it. Oh, it was the theorem 2.13. And restate what the theorem was, and then you can use it. If it has a proof, then you could just use the conclusion of the theorem. Um, this is something that you'll probably find yourself doing way more often than you might first expect, is to write down something because of the definition. So that's why definitions in mathematics are so important. Um, when uh, when something is given to be, some function is given to be bounded, you know you can write down, oh, it's bounded, so there exists a constant that's bigger than any input, sorry, any output of the function. So you could write that down. But those are given by definition. You might be able to write something down because it's part of the hypothesis of the theorem. So if some hypothesis, then some conclusion. To prove that, you could start with the hypothesis as given. So you can write down the hypothesis for free. Um, you might be able to write down something because you have already concluded that in earlier parts of your proof. So sometimes proof structure is complex enough where you might have to leave an argument to say something else, and then you come back to where you were at. Um, so if you've already shown it, you don't have to reprove it, right? Yeah, you could just write down what you have shown before. Um, and anything that's true by rules of logic. So if A implies B and you have an A, then you have B. Or um, if A is true and B is true, then you can write down A and B. So things like that. So if A implies B, then that's the same thing as not B implies not A. These logical equivalencies are determined by these rules of logic, and you could use that anytime you want. Um, okay, so these are the 6 ways, 6 things you're allowed to write down. If you're not using any of these 6 ways, then you probably have some leap in the logic. Even if the statement seems obvious to you, there's something that you're skipping. So try to think about how to fill in that gap. Okay, that's it for today's videos. There's a part two to this writing conventions that I'll post on Thursday as well. All right, until then, I'll see you and stay healthy.